Grapes are often tested prior to harvest for sugar level, which is measured in Brix, pH, and titratable acidity. A refractometer is an instrument that measures the refractive index of a solution to obtain the Brix. It is calibrated at a temperature of 68 degrees Fahrenheit for most meters, and is primarily used for juice samples that have not started fermentation. A hydrometer measures the specific gravity of a liquid sample converted to Brix. It's used to test both juice and wine as it progresses through fermentation. The equipment needed to test Brix in juice with a refractometer include a refractometer, eyedropper, juice sample, a DI water bottle, and chem wipes. The equipment needed to test Brix in juice with a hydrometer include a hydrometer, a 250 ml graduated cylinder, and a 150 to 200 ml juice sample. A sample of grapes must be obtained. The sample should represent the variety of growing conditions and not just from a single plant to obtain a representative sample of the vineyard. Once the grapes are obtained, they'll need to be crushed. This can be done manually by placing the grape clusters into a clean strainer. With gloved hands, crush the grapes thoroughly, capturing the extracted juice into a clean container. Mix the sample thoroughly to provide a homogeneous sample and then allow the solids to settle. Extract a sample for testing with a refractometer or a larger 150 to 250 ml sample for testing with a hydrometer. In preparation for testing juice with a refractometer, it's a good practice to verify the calibration of the device using DI water. First, clean the refractive lens prism with DI water. Place a sample of the DI water onto the prism. Observe the sample measurement in the viewfinder. Verify the sample measurement is 0.0. And then wipe the prism surface dry with a chem wipe. The refractometer is now ready for sampling. To test a juice sample using the refractometer, make sure the prism surface is clean and dry. Place 1 to 2 drops of the juice sample onto the prism and close the prism cover. Observe sample measurement in the viewfinder. The scale is visible through the viewfinder, and the measurement is taken by observing a blue line on the scale indicating the Brix level of that sample. Record the sample measurement as the scale point when the blue line becomes solid. Rinse the prism with DI water between samples and wipe the surface dry with a chemi wipe. Testing a juice or wine sample using a hydrometer requires a larger product sample of 150 to 200 milliliters. Place the strained and settled juice sample into a 250 ml graduated cylinder. Select the appropriate clean hydrometer for the anticipated Brix level. Hydrometers have unique scale ranges, so choose the hydrometer appropriate for the expected Brix level of your sample. Place the hydrometer into the cylinder containing your juice sample, giving the hydrometer a slight spinning action. Allow the hydrometer to stabilize in the sample before taking a reading. Record the hydrometer reading where the hydrometer scale point is in contact with the sample in the graduated cylinder. Hydrometers are calibrated for measuring liquids at specific temperature. Brix hydrometers are standardized at 20 degrees centigrade. If your sample is not at 20 degrees centigrade, a conversion chart will be needed to accurately determine the Brix level. Some Brix hydrometers include a plus and a minus range. A dry wine sample will finish in the negative portion of this scale. Equipment used for testing Brix should be cleaned thoroughly between each test and after final use to prevent cross-contamination of samples. Clean the prism surface and lens cover with DI water immediately after sampling. Dry the lens with a chem wipe. Clean the exterior of the refractometer with a damp cloth to remove any spilled juice samples.
To learn more about the Vineyard and Winery Technology program offered at Yakima Valley Community College, visit us online at www.yvcc.edu/wine.
This material is based upon work supported by the National Science Foundation under grant number 1003721. Any opinions, findings, and conclusions or recommendations expressed in this material are those of the authors and do not necessarily reflect the views of the National Science Foundation.